7 things that programmers say. 7 things that lower the code quality. 7 things that slow teams down. 7 things that erode our reputation as software engineers. 7 things that don't deliver any value. 7 things that frustrate people. 7 things we say but shouldn't say. Let's look at them. The first one: I don't have time for a code review right now, so I'll quickly approve your merge request. The problem with this is that your code quality isn't reviewed. Your interfaces, your separation of concerns, and your coupling, which are the most important things in my opinion for code quality, they're not reviewed. Your approach to the solution isn't reviewed. And the actual problem is that on the short term, yes, you may have a bug in production and that could have been prevented. But there's also things like you are now the only one who knows about this specific thing you built. There's no knowledge sharing, which is what code reviews also are for. On the long term, the actual problem is code quality decline, which means you're slowing your team down. Not right now, a year from now, 2 years from now. The software will have an expiry date. It will become very difficult to change because everything will break. You touch X, suddenly Y breaks. But I wasn't touching that at all. Yes, but now there's coupling. Now there's no great separation of concerns. There's all kinds of things that will go wrong that turn code into a big ball of mud if you don't have this continuous vigilance on code quality. The fix? Make time. Do it now. Yes, there's pressure. Yes, there's circumstances. But if you don't do it now, you will never do it because circumstances will not have changed. There will not be an easier time where there will be less pressure, where you have time to fix this kind of thing. That's not how projects work. Second one, test-driven development costs more time, so I don't do it. The problem with this is you don't yet realize how TDD will save you time instead of cost you time. You don't yet realize what the true value of TDD is. The actual problem is the same as the previous one. You are slowing the team down on the long run by choosing to decline the code quality right now. By not picking the right solution, you will have a problem a year from now, 2 years from now. The fix is straightforward. Learn TDD. You have to realize TDD is a skill. You can learn it. If you don't have the skill right now, you can practice it, you can get better at it, and at some point you will achieve the result. You will know TDD. Then apply TDD all the time. Second step, apply code reviews all the time. Do the 2-part code review that I've talked about in one of my previous videos. This really helps get the code quality up and prevent your code slowly turning into a big ball of mud. Prevent over time your team to get slower instead of faster. Next one, I don't have time to refactor this. We'll do it later. And of course the problem with this one is you won't do it later. The situation hasn't changed. The pressure isn't gone. Therefore, this pile of, maybe you could call it tech debt, it just grows. It will never get fixed. The code quality lowers. The actual problem is the same as the previous ones. Slowly your code will turn into a big ball of mud. The job will become undoable. You are again slowing your team down on the long run. The fix? Take the time to refactor this. You need to tell your product owner or your client the bad news. Yes, I know we will overrun. Yes, I know this is not what we promised, not what we estimated, not whatever. It is what it is. We need to take the time right now because otherwise your software will get an expiry date. 2 years from now, you won't be able to add features anymore. Is that what you want? No, of course they don't want that. So let's take the time right now. Let's fix it. Go refactor, and don't do it alone. Do it together with your colleagues. Talk about the best solution. Do pair programming. Do code reviews together. Again, the 2-part code review is a really good way to increase code quality. Make sure you pick the right solution. And the next one, that would take too long, so I went with a quick and dirty solution instead. And the problem here is probably pressure. Something you need to break through to actually pick the right solution over the quick solution. Again, for the same reasons I discussed before. But there could be an alternative cause. It could be you could be too shy or too scared to admit that you don't know of a better solution. You might not be able to ask for help because your culture doesn't have a high psychological safety. And this will also create a problem in the long run. But for you, for your career, a few years from now, your manager will tell you, no, you won't get that promotion because you haven't grown as much as we've expected you to. And that's because You didn't ask for help. You didn't create the opportunity for growth by continuously talking about code all the time, by having 2-part code reviews, and by talking about code in the form of pair programming. And if the problem is pressure, yes, on the long term, a bug will turn up in production. The code quality will have declined. Refactor will take too long. It won't happen. Same story as the other ones I've discussed. In the long run, you'll slow your team down. And the fix is pair programming or mob programming, or at least talking with colleagues, talking with peers about the code, about the problem that you're having. This will improve it. This will at least prevent it in the future from happening again, because the moment you talk about these things all the time, you will come across less of these problems which you won't know to solve in the right way, quickly as well. We want to get to a situation where you're so experienced by talking to everybody that there's no nice solution that takes a lot of time, or the quick and dirty solution. No, there's the quick and nice solution. That's what you get with experience. And the next one, it's a feature, not a bug. And this is a perspective problem. Whatever you call it, it's not what the user or the client is expecting, and you need to acknowledge that. By saying this sentence, it's a feature, not a bug, you're effectively saying you're wrong. And then you have a debate about who's right or wrong. That's not the position you want to be in. The actual problem is that you're not connecting to your client or user. You're not delivering value for them. And therefore the fix is to empathize. The fix is to listen. The fix is to acknowledge, and then to work with them together, to collaborate towards the solution. Or if you can't solve it, the workaround. Maybe your interface, because they depend on some third party for something, and that party is down and you suddenly have an error in your interface. Maybe the fix isn't solving that for the user or the client. Maybe the fix is a workaround so that the UI handles it more gracefully. The next one, I'm guessing it's an issue on their side. And the problem here is that something you depend on, maybe a different third party or some other system internally, something you depend on, behaves in a way you didn't expect. But by saying this, you're effectively saying it's their fault. And you're not owning up to your part in this. You could have handled it gracefully. You could have added defensive coding. This could have been a test case. Why didn't you predict the situation? The actual problem here is that you are not taking responsibility for your part in it. You're pointing the finger. The user or the client doesn't care on whose side it is. It needs to be fixed. The value needs to be added. Your job is not done until the job is done. The fix is to add a test case, to add this specific scenario that the thing that is third party that you depend on that is not working, that you're testing for that you're handling it gracefully, even if you cannot fix it, that at least the problem is softened or mitigated some way. And the last one is a very famous one. It works on my machine. And the problem here is you're deflecting. You're not taking responsibility for your mistake, as if you expected it to go wrong. No, of course not. You expected that the code you've written on your machine also works on that other machine. Your mistake, and you should own up to that, is that these two environments aren't equal enough. There's something different. Something is changed that causes this stuff to fail. Either it's being used differently, or the difference between your laptop and the Kubernetes environment makes this go wrong somehow. But you need to own up to the mistake. The actual problem is that you haven't built and tested it for real life usage scenarios. Something is different. You need to get to the root of that difference, because that's why it fails on another machine, in another usage scenario, in another environment. And the fix is, besides solving the problem itself, besides figuring out what is different, you should realize that whatever is different, whatever is causing that, it warrants further investigation, because you want to eliminate all these differences as much as possible. If you can figure out a way to run your local environment in a Docker container so that it's closer to the actual Kubernetes environment that is running in the end, this will help you solve problems and find bugs earlier. It will prevent this from happening really late in production. No, suddenly you get quick feedback on your local development environment. Figure out how your testing is not realistic enough. Then change something in your workflow to get it closer to the realistic usage scenario. So those were 7 things I've heard too often in my career. Let's try to be better than this. We're professionals. I've heard many of these things in various different forms, but in the end they all result in problems. The biggest mistake we as an industry can make is to write software that slowly degrades over time. A decrease in code quality will always result in teams delivering slower and slower and slower over time. Teams will start to feel this a year or 2 years from now. And this is exactly the opposite of what we should be achieving. We're trying in Scrum and Kanban, we're trying to move faster and faster. That's why we optimize in these things called retrospectives. That's why we work together. All these mechanisms are there to get us to move faster. And these things are solved by using test-driven development, the two-part code review, using pair programming. All of this are different ways to talk about code on a detailed enough level to get to the heart of what matters, to increase the quality of the code. You need to be unrelenting in your focus on code quality. This is the way to prevent code rot. And that's it. I hope you like this. If you have any thoughts or questions, or if you have an idea for a future video, leave a comment and subscribe. Thank you very much for watching.